Good morning. Today I'm doing a little test with this cutter. It's a straight 6mm 2-flute cutter. It's got a solid tungsten carbide tip on it, and it's for cutting birch ply. This test is a bit unusual. It's for a guy who has an older style CNC machine that doesn't have the same kind of spindle speed as these modern spindles have. It only goes about 18,000 RPM. So I'm just doing a quick test for him to work out what kind of feed speed we should be using. So I've programmed 6 shapes to cut out, and I can use 6 different feed speeds. I think I'm going to start at 2.5 meters a minute. His spindle goes, I think it goes about 18,000 RPM, so I'm going to set my spindle speed at 18,000 RPM. I'm going to cut the first one, see how I get on from there, and then I'll cut some more, see what kind of finish I get, see what I can push the speed up to. It's important when you're trying to work out how fast you can go, and the speed that I say for him it isn't necessarily the speed he'll be able to go, but it'll be a starting point. But the important thing is that we're creating chips and not dust. If you start to see dust coming out of your cutter, that is because the cutter has cut a chip, and the chip's curled up, and then before the cutter's moved out the way of the chip, it's come back through and cut the chip again. And when you do that, what happens is the heat that was in the chip you put back into the cutter, so you tend to get burning with the cutter if you do that. What you really need to be able to do is create a chip, throw the chip out of the cut, which will take the heat out of the cut as well, because the heat will be in the chip, or at least some of the heat will be in the chip. So if you could throw the chip out of the cut, you just throw some of the heat out with it. Obviously if you cut it again, you start embedding that heat back into the cutter, and that's not good for the cutter, and obviously you're cutting that chip again, so to create the dust, and that's not good either, and it does tend to make it burn, gives you a poorer finish. So anyway, it's a 1/2 inch collet. On my machine I've got one of these bearing collet nuts, and they're really good because when you torque up the collet, the bearing turns as you turn the collet, and that means that you're not actually graunching this round or trying to graunch this round inside the taper in your spindle. What happens is that this bearing here turns. So those are the bits I'm using. It's important to use a good collet because it's all about the fit. If it fits well, then you're gripping all the way round the cutter. And if you're struggling with quality of cut, it is worth looking at your collet and making sure it's not your collet causing it. They are a chuck away item, so they don't last forever, they do wear out, and they should be inspected and they should be cleaned. Right, anyway, enough of that, let's see how we go. Looks like it might have overcut it a couple of times. Getting a good finish there, so I'm going to go a bit faster. I think for the next one I'm going to go, well, I've gone 2.5, I'm sort of aiming towards 5. I think I'm going to go 3.5 next, because I reckon it'll easily cut that, so let's see what it does. obviously I didn't want these are little tiny bits and I didn't want them to ping across. So I'll cut those out and then we'll have a look at the finish on the edge of the ply, and I'll come back to you with that. Okay, so here are the results. I've just whizzed these out quickly on the bandsaw, and then I've cut across the... I'd left about 1/2 mm onion skin at the bottom, so it didn't ping across the workshop. And I've just cut that off with a scalpel. So I'm going to try and show you really close up what the results are. And that's looking across the top of them. Now, I don't know if I can get this in focus, but you can see on the left we've got 2.5, and on the right we've got all the way up to 6 meters a minute. So I think you'll see from that you can probably go a lot faster than expected. We're not looking in close enough to really see any discrepancies in any of the cuts. So just to go back over it, at this end we've got 2.5 and at this end we've got 6 meters a minute. So I think with that cutter you could quite easily go 6 meters a minute. I think probably about 5 from listening to it is probably the sweet spot. It would vary from machine to machine, and I think that I'd have to do an extended test to find out exactly where the sweet spot was, and find out exactly where, because you'd start to see it show up in cutter life. Obviously, if you're recutting your chip, it reduces your cutter life. So that really is how you tell if you are going fast enough. But I mean, I'm quite surprised that in that variation in feed speeds that we go in there, that we're getting a cut like that, especially at such a low spindle speed. Really, 18,000 RPM is quite slow for a 6mm cutter. Right, well, thanks for watching.